Imagine a world where today's most complex problems, from climate change to drug discovery, are solved in the blink of an eye. Google believes this future, powered by quantum computing, is just a decade away, and they're betting big on leading the charge. But here's the twist. This quantum leap could also shatter our current cybersecurity defenses, leaving everything from your bank account to national secrets vulnerable. Are we ready for this double-edged sword? Google's CEO, Sundar Pichai, has boldly predicted that commercially viable quantum computers are within reach in the next few years, with full realization expected within a decade. This isn't just about faster processors, it's about fundamentally changing how we compute, unlocking potential previously deemed impossible, and positioning Google at the forefront of this technological revolution. This ambition is fueled, in part, by their recent successes, including the prestigious Nobel Prize in Physics awarded to researchers deeply connected to Google's quantum efforts. This marks the second year in a row Google-affiliated research has been awarded a Nobel Prize, following last year's recognition of DeepMind's AlphaFold AI. Some analysts suggest this winning streak signals Google's confidence in dominating not only the AI landscape but also the emerging quantum computing era, leveraging its immense research and development (R&D) capabilities. Pichai shared his optimistic outlook during a conversation with Salesforce CEO Marc Benioff at Dreamforce 2025, Salesforce's annual developer conference held in San Francisco on October 16. He specifically stated, "Google plans to have a commercially viable quantum computer within a few years," reinforcing his confidence in the 10-year timeframe. However, this excitement is tempered by serious concerns within the tech industry. The sheer power of quantum computers poses a significant threat to existing encryption and security systems. Current encryption methods, which protect our sensitive data online, could be rendered obsolete by quantum computers capable of cracking them with ease. Pichai acknowledged this risk, cautioning, "I am confident that within 3 to 5 years, we will reach a point where we need to adapt to quantum computing from an encryption perspective." And this is the part most people miss. He further emphasized the urgent need for proactive measures, stating, "Everyone needs to be mindful of the issue that there could be a very serious trust gap at the moment when vulnerabilities arise at all points, including cryptocurrencies. This vulnerability extends beyond traditional financial systems, potentially impacting everything from blockchain technologies to secure communications." Pichai's optimism is clearly bolstered by the recent Nobel Prize in Physics, awarded to John Clauser, Michel, Devoret, and John Martinis for their groundbreaking research on quantum mechanical effects in the macroscopic world. Notably, Michel Devoret is a professor at Yale and UC Santa Barbara, as well as a senior scientist for Google Quantum AI. John Martinis is also an emeritus professor at UC Santa Barbara and contributed to quantum hardware research at Google from 2014 to 2020. This achievement underscores Google's deep investment and expertise in quantum computing, solidifying its position as a leader in the field. Highlighting Google's long-term commitment, Pichai recounted a recent visit to Google's quantum research lab in Santa Barbara, stating, 2 weeks ago, I visited Google's quantum research lab in Santa Barbara to meet the team, and a day later, our senior scientist received the Nobel Prize." He further drew a parallel between the quantum computing team and Google's Tensor Processing Unit, TPU, team, emphasizing the strategic importance of this research. Google has been researching quantum for over a decade, and from a product perspective, the quantum computing team is no different from the Tensor Processing Unit, TPU, team. Just as the early development and deployment of TPUs gave Google a significant advantage in building efficient data centers for AI, the company aims to leverage its quantum expertise to secure a dominant position in the future quantum computing infrastructure. Think of it as building the roads and bridges of the quantum era. But here's where it gets controversial. While Google aims to lead in quantum computing, they also face fierce competition in the AI arena. OpenAI, with its popular ChatGPT, has arguably captured the public's imagination. Pichai addressed this directly, acknowledging OpenAI's success in the consumer market and admitting that Google should have seized that initial momentum. Responding to Benioff's query about headlines suggesting Google has a competitor and OpenAI is the true AI leader after OpenAI released ChatGPT, Pichai admitted, "I recognize OpenAI's merit in preemptively releasing to the consumer market. Google should have captured that moment and executed well, openly acknowledging the missed opportunity." However, Pichai emphasized Google's underlying strengths and its plans for a powerful comeback. He pointed to Google's extensive infrastructure and world-class research teams, including Google Research, Google Brain, and Google DeepMind. He revealed that Google plans to integrate these capabilities to release Gemini 3.0 this year, a next-generation AI agent. Google has been actively implementing transformers since their announcement in 2017, achieving dramatic improvements in search, photos, and other areas. We had also developed a chatbot that became famous for an engineer thinking it had consciousness 6 months before ChatGPT's release, Pichai stated. He further elaborated that Google's chatbot wasn't released earlier due to safety concerns, suggesting that the different operational environments of a startup like OpenAI and a large corporation like Google influence their respective approaches to AI deployment. This implies that Google prioritizes responsible AI development, even if it means being slightly later to market. Pichai concluded by confidently stating, Gemini 3.0 will be an even more powerful AI agent that has made more noticeable progress than in the past few years. Ultimately, Google's vision is ambitious, to lead both the AI and quantum computing revolutions. But can they navigate the ethical and security challenges that come with such powerful technologies? And is their focus on responsible AI development a strength or a weakness in a rapidly evolving landscape? What do you think? Is Google's measured approach the right strategy, or are they ceding too much ground to more agile competitors? Share your thoughts in the comments below.